Hello and good day, sir. My name is Jun from Section 1, Group 2, and these are my group mates. In this video, I will be presenting the validation method for our assignment 3 using ANSYS. First of all, the first step is to open the workbench of the ANSYS. Then we create a model. Then we create a geometry using the dimension we just calculated. First of all, go to the XY plane. And then we have just done drawing our mess, our passenger coach. Next, let's proceed to the model. We wanted to edit the model. So now we have the model interface. First of all, we need to make sure the material is as intended. Structural steel, yes. Next, we start drawing the connection. Insert, we want spring, which is a coupler. For the scope, select here, applied. Aha. So why the spring go here? It's because we didn't set our reference x coordinate properly. So since we know that our origin is at here, you can see it come out from here, right? So basically, we need to reset the reference x coordinate to here so that it could go at this direction. So how can we do it? Basically, just the length of the mass A plus 100 millimeter plus the length of the mass B and plus 100 millimeter so that it could come up here at 100 millimeter of length. Now let's just do some simple calculations. Just copy paste it to the reference x coordinate. Here we go. You can see the spring come out here at the length of 100 millimeter. So far we have done it. All the spring is added. Next we go to generate the mesh. After the mesh is being generated, we need to set the boundary condition by clicking this remote displacement. Lastly, we need to go to the analysis setting and set the max MOHD. Lastly, we just solve it. So after it's done calculating, we can click solution and we can see the result we get. For the first design, the lowest natural frequency for this system will be 2.3887 Hz. And still same for the first design, the highest natural frequency will be 5.0052 Hz. Now let's click both of it and create mode shade result. So the mode shade for this one is, while the mass 1 is moving at 1, the mass 2 will be moving at 1.89. Now in this case, let's play the animation. This is the mode shade for the first design at the natural frequency of 5 Hz. And since both of the mass is moving at opposite direction, there will be a negative for this value. This basically means when the mass 1 moves 1 unit, the mass 2 will move the opposite direction at 0.396, which makes sense, right? Now let's proceed to do the analysis for the second design. The only difference between the first design and the second design is the stiffness of the spring, which for the second design case, all the spring have the same stiffness, which is 350 Newton per millimeter. Now you can do it very quick by just edit the connections. For this one, 350. And then just solve it again. For the second design, the lowest frequency is 2.6768 Hz and the highest natural frequency is 4.7315. Create mode shade. This is the mode shade for the second design and the lowest frequency of 2.6768 Hz. And you can see they are moving in the same direction. When the mass moves at 1, the mass 2 move at 1.151. And next, let's go to this. This is the mode shade for the second design when the frequency is at its highest, which is 4.73. And you can see they are moving at the opposite direction. And to calculate the mode shade, let's use the minimum divided by the maximum. Since it is moving at opposite direction, so this value need to be negative. So basically it means that when the mass 1 is moving at 1, the mass 2 is moving at negative 0.651. Negative 0.651 for the second natural frequency of the second design. And now let's compare the result we get using the ANSYS method and the result we get using the theoretical calculation method. And we can see the results are very, very similar. You may pause this video to see the similarity yourself. And that's all from me. Thank you.